Okay, we're going to look at graphing the parent functions of tangent, cotangent, secant, and cosecant. We are not going to be doing any shifts. We are just going to be looking at the parents. So let's start with tangent, and it's very helpful if you understand where asymptotes are. Oh, asymptotes. Okay, so here's what happens. Tangent is equal to the sine over the cosine. Okay, well, this is a problem because if cosine is 0, then the tangent is undefined. If cosine is 0, tangent is undefined. And you know what? Since we're here, let's talk about the, the secant. The secant is 1 over the cosine. So both tangent and secant have a denominator of cosine. So 0 in the denominator, asymptote on a graph. So again, if the cosine is 0, then the secant is undefined. Okay, and that means there's an asymptote. Undefined in a function is an asymptote on a graph. So undefined translates to a vertical asymptote. Okay, so let's look at where is the cosine 0. I think it's very helpful if we draw the parent function. Okay, so go ahead and draw your parent function. There is the parent cosine function. I think it's going to be helpful for us if we extend the graph past 2 pi and past 0 into some negative values. So I'm just going to go ahead and let's see, this would be 5 pi over 2, 3 pi, just a little bit, because it's going to help us when we look at both the parent, tangent, and secant. So just a little bit here. Let's just go to negative pi over 2 and negative pi. And it goes down as such. Ish. Okay, so where is the cosine? Oops, sorry. Where is the cosine 0? The cosine is 0 at pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2, etc. So the pi over 2 intervals, pi over 2 intervals, the cosine is 0. In a previous video, I talked a lot about domain and range of secants and cosecants. I don't know, it was a video about a week ago. You might want to go back and watch that if you didn't. Cosine is 0, tangent undefined. Cosine is 0, secant undefined. Undefined translates to a vertical asymptote on the graph. Okay, so this is exactly what I'm going to do. I'm going to use a different color, and I'm going to draw in asymptotes at all of these places. Should have warned you, I'm going to erase or white out part of this. Okay. Let's look at tangent, and then we'll go back and look at secant. Okay, so tangent. If sine is 0, then the tangent is 0. If the sine is 0, then the tangent is 0. Okay, so where is the sine 0? That is at 0. The sine is 0 at 0. The sine is 0 at pi. The sine is 0 at 2 pi, etc. And a tangent curve looks very similar to a cubic. A tangent curve looks very similar to a cubic. So it's hard to see. It's pink. Etc., etc. This is not fully correct. This is not fully correct. A wave, a cycle, is when the graph repeats itself. So from negative pi over 2 to pi over 2, that is a full tangent cycle. And between pi over 2 and 3 pi over 2, that is a full tangent cycle. What does that mean when I say it's a full tangent cycle? So let's go back to the 4 quadrants. I don't know, drew this a long time ago, but first quadrant, positive, positive. Second quadrant, negative, positive, negative, negative, positive, negative. In the first quadrant, tangent is positive. In the second quadrant, tangent is negative. But in the third quadrant, tangent goes back to being positive. In the fourth quadrant, the tangent goes back to being negative. So between 0 and pi, so here's 0, between 0 and pi, you've hit every tangent value possible. And when you get to the third quadrant, the tangent values begin to repeat themselves. Now, here's something you really, really wrap your head around. On the unit, so I'm looking at general, the first quadrant and the second quadrant. I'm not looking at the first quadrant on the tangent graph, the second quadrant on the tangent graph. What I am looking at is from 0 to 90, or pi over 2, from 90 to 180, or pi. So between 0 and 90, pi over 2, from 0 to 90 degrees, pi over 2, the tangent is positive. From 90 to 180, pi over 2 to pi, the tangent values are negative. We can go the backwards direction. This is going to matter when we do inverse functions in chapter 7. From 0, this is negative pi over 2. From 0 to negative pi over 2. From 0 to negative pi over 2, the tangent values are negative. 0, negative pi over 2, the tangent is negative. So the period of the tangent function, is pi, and its domain is negative pi over 2 to pi over 2. So what I'm going to do is I'm going to erase everything that's not between negative pi over 2 and pi over 2. There you go. I tried to erase this cosine curve. It didn't erase very well. The domain, negative pi over 2 to pi over 2, and the range is negative infinity to infinity. Again, did a video last week sometime, and I told you it was optional in class, but I would definitely recommend you go back and watch it. We're going to use this same concept to construct the secant curve. Same concept to construct a secant curve. Okay. So secant is 1 over cosine. And then I just talked previously about where the cosine is 0, the secant is undefined. So go ahead and draw yourself a parent cosine and extend it to the right and to the left. Here is the parent cosine curve, drawn terribly. Okay, so let's look at where the cosine is negative, secant is undefined. Where the cosine is negative, the secant is undefined. No, I'm sorry, where the cosine is 0. Start over. Where the cosine is 0, the secant is undefined. So where is the cosine 0? The cosine is 0 at pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2, etc., etc., etc. So because the cosine is 0 at negative pi over 2, positive pi over 2, blah, blah, which means the secant is undefined, that means you have asymptotes. Oh, I missed 3 pi over 2. Missed 3 pi over 2. Okay. Okay, so cosine and secant are reciprocal functions, not inverses. They are reciprocal functions. I find these much easier to graph. Okay, so if the cosine is 1, the reciprocal of 1 is 1. So the secant is also 1. At pi, the cosine is negative 1. The reciprocal of negative 1 is negative 1. So the secant is also negative 1. Okay, this is not going to sound super mathematical, but when you take the reciprocal of something, you flip the fraction, right? If the fraction is 1/2, the reciprocal is 2. If the fraction is 3/4, the reciprocal is 4/3. Yes? Okay, so I'm going to flip the graph. So this is downward facing, this like half parabola, this semicircle, it's downward facing. Secant is upward facing. And between pi over 2 and 3 pi over 2, the cosine is negative, the secant is negative. Between pi over 2 and 3 pi over 2, the cosine is below the x-axis. That's negative. The secant is below the x-axis, negative. Between negative pi over 2 and pi over 2, the cosine is above the x-axis. That's positive. So the secant is above the x-axis and is positive. Just like I did for the tangent, I'm just going to erase what I don't need. There is your parent cosecant, secant graph. The domain is all real numbers, x not including odd integer multiples of pi over 2. That's the domain. X, all real numbers, X not equal to odd integer multiples of pi over 2. And the range is negative infinity to negative 1 included. Negative 1 is included, that should be a bracket, in union with bracket 1 to infinity. Period is 2 pi. I'm going to use this same concept of reciprocal functions to graph cosecant and cotangent, which follow the same exact properties. So we have that the cosecant is 1 over sine, and the cotangent is cosine over sine. So where sine is 0, if sine is 0, cosecant is undefined, asymptote. If sine is 0, cotangent is undefined, therefore it's an asymptote. So I would draw for yourself 2 parent sine curves. Here are my 2 parent sine curves. I'll label the increments in a minute. If the sine is 0, the cosecant is undefined. So the sine is 0 at 0, pi, 2 pi, 3 pi, 4 pi, etc. 0, pi, 2 pi. Okay, so reciprocal function. So the cosecant, positive between 0 and pi. Cosecant, negative between pi and 2 pi. And there is your parent cosecant curve. Domain is all real numbers, X not equal to integer multiples of pi. Range is the same as it is for the secant curve. So that is negative infinity to negative 1 included in union with 1 to infinity. And the period is 2 pi. I should label this is 1 and this is negative 1. Okay, so cotangent. Where is the sine 0? The sine is 0 at 0. The sine is 0 at pi. Don't normally label 0. Okay. And goes through the point 1, 0. If the cosine is 0, the cotangent is 0. That's 0 right here. This is the reciprocal of the tangent. So it looks like a negative x cubed function. It mirrors x cubed. And that is it because the tangent slash cotangent values repeat themselves after you get into quadrants 3 and 4. Quadrant 3 and 4 values are the same as the quadrant 1 and 2 values. Be careful, I'm talking about quadrants, 1 and 2 on a unit circle. I'm not talking about quadrants 1 and 2 on a coordinate plane. They are different. This is quadrant 1 and 2 on the unit circle. This is quadrants 1 and 2 on the coordinate plane of the graph. The domain is all real numbers, and the range is 0 to pi. 0 and pi not being included. Last thing we're going to look at is rate of change. Remember, rate of change is fancy slope. Rate of change. F of x1 minus the f of x2 all over x1 minus x2. Or, vice versa, whatever. So let's find the rate of change. The f of x is equal to the secant of 2x. That's my function. And I want to find the rate of change from 0 to pi over 6. And find the rate of change from 0 to pi over 6. So I'm just going to say that my x1 is 0. So I want to find the f of 0. And I'm going to say my x2 is pi over 6. I need to find the f of pi over 6. And then all I need to do is plug in and get some values. So if x is 0, the f of 0 is going to be the secant of 2 times 0. Which is the secant of 0. And the f of pi over 6 is going to be the secant of 2 times pi over 6, which is the secant of pi over 3. The secant of 0 is 1. Let's just go over here. The secant of 0 is 1 over the cosine of 0, which is 1. Cosine of 0 is 1, 1 over 1 is 1. The secant of pi over 3, is equal to 1 over the cosine of pi over 3. Pi over 3, I wrote 6, should be a 3. So this is 1 over 1/2, which is 2. Gotta know your unit circle. Okay, so the f of x1 is 1. The f of x2 is 2 over 0 minus pi over 6, which is 1 over pi over 6. Negative 1 over negative pi over 6. Reciprocal is 6 over pi. That's just a number, what, 2-ish? It's just a number. So rate of change is just fancy slope. The homework, you do not have to graph any of the problems. You don't have to graph any of the problems. It's just a lot of evaluating.